I am going to talk about today is the preparation, properties and uses of nitric acid. Dear students, myself Dr. Digna Varghese. Nitric acid. Nitric acid is a nitrogen oxo acid of formula HNO3 in which the nitrogen atom is bonded to a hydroxy group and by equivalent bonds to the remaining two oxygen atoms. It has a role as a protic solvent and a reagent. It is a conjugate of acid of nitrate. Nitric acid red fuming appears as a pale yellow to reddish brown liquid generating red-brown fumes and having a suffocating odor. Very toxic by inhalation. Corrosive to metals or tissue. Prolonged exposure to low concentrations or short-term exposure to high concentrations may result in adverse health effects. Nitric acid, also known as aqua fortis, derived from a Latin word that means strong water, and spirit of nitre, is a highly corrosive mineral acid. The pure compound is colorless, but older samples tend to acquire a yellow cast due to the decomposition into oxides of nitrogen and water. When the solution contains more than 86% nitric acid, it is referred to as fuming nitric acid. Depending on the amount of nitrogen dioxide present, fuming nitric acid is further characterized as red fuming nitric acid at concentrations above 86% or white fuming nitric acid at concentrations above 95%. Preparation of nitric acid. In the lab, nitric acid is prepared by heating potassium nitrate or sodium nitrate and concentrated sulfuric acid in a glass retort at 150 to 200 degrees Celsius. A glass retort is a device used in the chemistry laboratory used for the dry distillation of substances. It consists of a spherical vessel with a long downward pointing neck. The liquid to be distilled is placed in the vessel and heated. The neck acts as a condenser, allowing the vapors to condense and flow along the neck to a collection vessel placed underneath. Here, in the case of nitric acid, the lab preparation, potassium nitrate or sodium nitrate is taken in the glass retort with concentrated sulfuric acid. This mixture is heated to 150 to 200 degrees Celsius. The issuing nitric acid vapors, that are brown vapors or fumes, condensed to a brown liquid that is collected in a collection vessel placed underneath, that is cooled receiver. So we get nitric acid from potassium nitrate with concentrated sulfuric acid. Manufacture of nitric acid. The most widely accepted procedure nowadays for the manufacture of nitric acid is the Ostwald's process. Wilhelm Ostwald developed this process and he patented it in 1902. Frederick Wilhelm Ostwald was a German chemist and philosopher. He got Nobel Prize in 1909. Ostwald process involves several steps. Step 1. The catalytic oxidation of ammonia by atmospheric oxygen. That is, a mixture of ammonia and air in the ratio 1:8 by volume under a pressure of about 9 atmospheric pressure is passed through a steel or aluminum catalyst chamber containing either platinum or rhodium platinum rhodium goes at 800 degrees Celsius to get nitric oxide. Step 2. Oxidation of nitric oxide by atmospheric oxygen. Nitric oxide is cooled and passed through the oxidation chamber where it combines with oxygen and of the air, giving nitrogen dioxide. Step 3. The dissolution of nitrogen dioxide in water in the presence of oxygen. That is, the gas mixture from the oxidation chamber, that is nitrogen dioxide, is mixed with air which contains oxygen and then passed up a tower, that is known as absorption tower, containing packing of earthen balls through which a spray of water descends. Nitrogen dioxide gets dissolved in water in the presence of oxygen or air to yield nitric acid. The solution of nitric acid thus obtained is dilute. This is then concentrated by suitable methods. Here we can see the flow diagram of Oswald process, which is used for creating nitric acid. First, the volume in the ratio 1:8, the ammonia and oxygen from air, that is passed to a catalyst chamber or a converter. In this, catalyst is either platinum gauze or platinum rhodium gauze, in which ammonia and oxygen is oxidized to nitrogen monoxide, that is nitric oxide. Nitric oxide passed to the oxidation chamber. Here, oxidation of nitric oxide occurs, which is converted to nitrogen dioxide. This nitrogen dioxide is mixed with air that contains oxygen, and it is passed to an absorption tower. In this tower, it is filled with earthen balls and water descends over for cooling, and nitrogen dioxide dissolved in this water to get nitric acid. If any waste gas is there, it is collected or exit from this tube. Nitric acid obtained here is dilute nitric acid, and this dilute nitric acid can be concentrated by any concentration methods. Concentration of the nitric acid solution. Concentrated nitric acid. The dilute nitric acid is concentrated up to 68% by distillation of azeotropic mixture of nitric acid and water having a specific gravity of 1.4048 gram per centimeter cube at 20 degrees Celsius. This concentrated nitric acid, that is 68% concentrated nitric acid, is further dehydrated to 98% by distilling concentrated sulfuric acid. We know concentrated sulfuric acid is a dehydrating agent. Strong cooling of this mixture to -42 degrees Celsius yields crystals of 98% nitric acid. Crystals of 98% nitric acid are separated and melted to get pure 100% anhydrous nitric acid. First, concentration is like this. First, it is dilute nitric acid concentrated to 68% by distillation, azeotropic mixture of nitric acid and water, and then this mixture is dehydrated further with the concentrated sulfuric acid to get 98% nitric acid, and 98% nitric acid are separated and melted to get the pure 100% anhydrous nitric acid. Physical properties of nitric acid. 100% anhydrous nitric acid is a colorless mobile liquid and its density is 1.512 gram per centimeter cube, and it solidifies at minus 42 degrees Celsius to form white crystals and boils at 83 degrees Celsius. Nitric acid is subject to thermal or light decomposition, and for this reason it was often stored in brown glass bottles. That is, nitric acid decomposes to water, nitrogen dioxide and oxygen. Chemical properties of nitric acid. Here we are discussing its action of heat, acidic nature, oxidizing properties, action with metals, reaction with metals more electropositive than hydrogen, that is, reaction with metals less electropositive than hydrogen, action with nonmetals, action with metalloids, action with inorganic compounds, action with organic compounds. First reaction is action of heat. Nitric acid decomposes upon strong heating to nitrogen dioxide, oxygen and water. Acidic nature of nitric acid. In aqueous solution, nitric acid behaves as a strong acid giving hydronium ion and nitrate ions. It thus turns blue litmus red, and it can react with bases and forming sodium nitrate and water. Oxidizing properties. Nitric acid behaves as a strong oxidizing agent. Its action on metals, nonmetals, metalloids and compounds are considered here as the oxidizing properties for nitric acid. Nitric acid decomposes as nitrogen dioxide, water and oxygen. This oxygen is responsible for its oxidizing properties. Nitric acid acts as a powerful oxidizing agent. First reaction is with action with metals. Concentrated nitric acid oxidizes most metals except noble metals such as gold and platinum. The product of the reduction of nitric acid is also depends upon the concentration of the acid. Metals undergoing oxidation to metal nitrates by nitric acid, and nitric acid undergoes reduction, and the reduction products of reduction of nitric acid depends upon the concentration of the nitric acid used, and the temperature also considered, and the nature of the metal undergoing oxidation. Possible sequence of showing the reduction of nitric acid is: nitric acid undergoes reduction to nitrogen dioxide. In this, nitric acid has +5, nitrogen is in the +5 oxidation state. Here nitrogen is in the +4 oxidation state. Here in nitric oxide it is +2 oxidation state, and in nitrous oxide it is +1 oxidation state, and nitrogen it is 0, and in sometimes it is shows ammonium nitrate, that is -3 its oxidation number. Reaction with metals more electropositive than hydrogen. With very cold dilute nitric acid. Here the metal reacts with very cold dilute nitric acid to give corresponding nitrate, and with the evolution of hydrogen. Here the metal is used for this type of oxidation reaction is magnesium and zinc. With the cold dilute nitric acid, Here some metals reacts with cold dilute nitric acid giving metal nitrate, ammonium nitrate and water. Here using the metal as for oxidation is magnesium, zinc and iron. If zinc is used, we will get zinc nitrate, ammonium nitrate and water. Iron is used, iron nitrate, ammonium nitrate and water. If magnesia is used, magnesium nitrate, ammonium nitrate and water. But in the case of lead, it will give lead nitrate. Instead of ammonium nitrate, it will give nitrogen monoxide, that is nitric oxide with water. Metals reacts with nitric acid, that is in the condition is cold dilute nitric acid. Zinc, magnesium, iron give metal nitrate with ammonium nitrate, but lead give metal nitrate with nitric oxide instead of ammonium nitrate. Next reaction is with hot dilute nitric acid. With hot dilute nitric acid, zinc, magnesium will give corresponding nitrates and nitrous oxide and water. We know nitrous oxide is known as laughing gas. With concentrated nitric acid, here reaction of magnesium or zinc or lead reacts with concentrated nitric acid giving corresponding nitrates and nitrogen dioxide with water. But tin reacts with concentrated nitric acid, it will give stannic acid, metastannic acid with nitrogen dioxide and water. If iron reacts with moderately concentrated nitric acid, it will give ferric nitrate, nitrogen dioxide and water. But iron reacts with concentrated nitric acid, it will give a thin film of ferrosoferric oxide. Ferrosoferric oxide. That is, here iron is in the +2 oxidation state, here iron is in the +3 oxidation state. So ferrosoferric oxide with nitrogen dioxide and water. That means when iron is treated with concentrated nitric acid, a thin film of ferrosoferric oxide gets deposited on the surface, which prevents further reaction with metal with this particular acid. When this happens, the metal is said to have become passive. This process is known as passivation of the metal, and the result is called passivity. Similar reactions with aluminium, chromium, nickel are also rendered passive by concentrated nitric acid due to the formation of a thin protective layer of the metal oxide on the surface of the metal that inhibits further reaction. From these reactions we can see different byproducts with corresponding metal nitrate are obtained due to the reduction of nitric acid. That depends upon the nature of the acid, that is temperature of the reaction condition. If it is a cold dilute or concentrated, and depends upon the concentration of the acid, temperature and the nature of the acid, it will give different products, and also with the different metals. Here lead produces nitric oxide, but same reaction with magnesium, zinc and iron, it will give ammonium nitrate as reduction product of nitric acid. Reaction with metals less electropositive than hydrogen, that is reaction of metals with dilute nitric acid. It reacts with metals like copper, silver or mercury and giving metal nitrate, nitric oxide and water. Reaction with the same metal with concentrated nitric acid, it will give corresponding metal nitrate, but instead of nitric oxide, here we will get nitrogen dioxide with water. Action of noble metals, that is gold and platinum with aqua regia. Aqua regia is a mixture of concentrated nitric acid and concentrated hydrochloric acid in the proportion 1:3 by volume. So gold reacts with aqua regia, it will converted into chloroauric acid having the formula HAuCl4 with nitrosyl chloride and water. Platinum reacts with aqua regia, it will give chloroplatinic acid, that is H2PtCl6 with nitrosyl chloride and water. Only noble metals reacts with aqua regia. Action with non-metals. Concentrated nitric acid oxidizes several non-metals like carbon. It will oxidizes to carbon dioxide, nitrogen dioxide and water. Sulfur to sulfuric acid and along with nitrogen dioxide and water. Phosphorus to phosphoric acid, H3PO4, nitrogen dioxide and water. Action with metalloids. Arsenic reacts with nitric acid to give arsenic acid having the formula H3ASO4 with nitrogen dioxide and water. Antimony reacts with nitric acid to give antimonic acid H3SbO4 with nitrogen dioxide and water. Action with inorganic compounds. Both concentrated nitric acid and dilute nitric acid oxidize several inorganic compounds. During such oxidations, nitric acid gets reduced to nitrogen dioxide when concentrated nitric acid is used, and when dilute nitric acid is used, it is reduced to nitric oxide. Here we can see with hydrogen sulfide as an inorganic compound which reacts with concentrated nitric acid, and the product is nitrogen dioxide, water and sulfur. The same compound reacts with dilute nitric acid, the nitric acid reduced to nitric oxide, water and sulfur. Another example is with sulfur dioxide. Sulfur dioxide reacts with concentrated nitric acid to give sulfuric acid and nitrogen dioxide. Dilute nitric acid with sulfur dioxide reacts to give sulfuric acid and nitric oxide. Another reaction is with ferric salts. In the ferrous salts oxidized to ferric salts in the presence of dilute and concentrated nitric acid in the presence of sulfuric acid. We will get ferrous sulfate reacts with concentrated nitric acid in presence of sulfuric acid. We will get ferric sulfate nitrogen dioxide and water. Ferrous sulfate in presence of sulfuric acid with dilute nitric acid will give ferric sulfate, nitric oxide and water. Action with organic compounds. Nitric acid acts as an oxidizing and nitrating agent in its reaction with organic compounds. Here we can see some examples, that is, concentrated nitric acid reacts with sucrose and which is converted to oxalic acid and nitrogen dioxide and water. Another reaction is with benzene, reacts with concentrated sulfuric acid and concentrated nitric acid. It will undergo nitration and it will give nitrobenzene with water. So nitric acid acts as an oxidizing agent as well as nitrating agent with organic compounds. Here it shows oxidizing action, here it shows its nitrating action. Uses of nitric acid. Nitric acid is used in the manufacture of ammonium nitrate, that is for the fertilizer, and other nitrates for use in various industrial fields. And it is also used for the preparation of various organic nitro compounds by its nitrating action, including the explosives like nitroglycerin, trinitrotoluene, and it is also used in the pickling of stainless steel. Pickling means removal of oxide from the surface. It is also used as an oxidizer in rocket fuels. It acts as a laboratory reagent in qualitative and quantitative analysis. It is used for the purification of gold and silver. Thank you for your attention.